Hi, how are you guys? How are you? Today is April 28. Today our class about verifying trig identities. This is the second part. There is no limit for verifying trig identities. Only we give an idea how to deal with these problems. But if you practice more, you understand more. I want to do today the last class for the trig identities. Then after that, after I finish this, I will go to the trig equation, how to solve the trig equation. As always, don't forget to like and subscribe. Let us start and see what we have. I'm gonna have only 16 minutes. for this class. Okay, let us start with the first one. Let us start with the first problem. We want to verify that one over tan x let me just minimize a little. Okay, a little bit bigger. Okay, 1 over tan x plus tan x equals secant x cosecant x. Now remember, that's too many things to remember. You know tan x is sine 1 over tan x. Look here, 1 over tan x is cotan x. You have to remember this, cotan. Right? You have to know this one way, and cotan x equal cosine x over sine x, and tan x equals sine x over cosine x. Go back here, change this to cotan x plus this guy gonna be sine x over cosine x. Am I right? Yes. Then the tan becomes cotan sine over 1 over tan becomes cotan, and cotan is sine over cosine. 1 over tan cotan. Cotan is cosine x over sine x plus sine x. You following me? I'm dealing only with the right side of the equation. I need to prove this to be that. I have two different denominators, right? My common denominator will be what? Sine x, cosine x. You multiply the two denominators. Then, okay, now here, since I have sine and cosine, you multiply this by cosine, and this by sine, and this by sine, and this by cosine. Cosine and cosine, cosine square x. I have a student here, his name is Ashraf. Ashraf, he's telling me cosine square plus sine square equal to what? 1, right? Ashraf is telling me, do you know, he's telling me that, do you know that sine square plus cosine square equal to 1? Yes. Then this guy becomes 1 over sine x and cosine x. The last step, what 1 over sine? 1 over sine is what? And 1 over sine is cosecant, right? 1 over sine, cosecant. 1 over cosine is secant. That's what we have to prove. Secant x. Good? Okay. Then one more time. 1 over tan. 1 over tan is cotan. Tan sine over cosine. Cotan is cosine over sine. Now we have sine and we have cosine. We have to have the same denominator. We multiply this by cosine, this by sine, cosine and cosine, cosine square, sine and sine square, and we know that sine square plus cosine square equal to 1. The second one, number 3. What we have, Mr. Student, my student, I have sine x and sine x, right? I can't take this as what? GCF, great scale factor, right? You take sine square, sine x out. Taking this as GCF means, take this as GCF means you divide by what? Sine x, 1. When you divide by sine x, what left here? Cosine square x. Good. We are dealing only with the left side. We have to prove this side equal to this side. What I did, I took sine x out, right? Then you open parentheses. Sine x divided by sine x is what? 1. Anything by itself is 1. U by u is 1. Me by me is 1. X over x is 1. Y over y is 1. And in the other side, when you divide by sine, the sine cancel and lift 1 minus cosine square. Again, when I hear somebody saying, oh yes, you give out this 1 minus cosine square x equal from the previous class, right? Equals sine square. Wow, yes. Then this guy, sine x, and this guy, what we said, 1 minus cosine is equal to a sine square. What's sine x times sine square x? Sine cube x. Good? Okay. Okay, in this problem, I left something here. Look, he wants me to prove cosine alpha over 1 sine alpha plus 1 plus sine alpha over cosine alpha to secant alpha. I left a space here. I explained this. Please go to the previous video. In the previous video, I explained the idea of the conjugate of the denominator. You multiply by the conjugate. What's my conjugate here? 1 minus sine alpha. Then 1 plus sine alpha has a conjugate 1 minus sine alpha. 1 minus sine alpha. Now, okay. I explain if you multiply this in the side a minus b, everyone needs this. Every student needs this. A plus b is a square minus b square. This has to be like your name. A minus b, a plus b, a square minus b square. That will be 1 minus sine square alpha, and you multiply derivative. Cosine alpha minus cosine alpha sine alpha. Or I can leave cosine alpha. I'm going to take this one because I can tell there's something here. Go. I'm going to leave cosine alpha in blue and 1 minus sine alpha. Okay. Why? Because I have something here, 1 plus sine alpha over cosine alpha. This problem is a very good problem. What 1 minus sine squared, Mr. Mike? Mike here is telling me 1 minus sine square alpha equal to cosine square alpha. Thank you, Mike. Thank you. Cosine alpha, 1 minus sine alpha, okay, and 1 minus sine square equal cosine square alpha plus 1 plus sine alpha over cosine alpha. Okay. J is saying I can cancel what? This and left with cosine alpha. Then what's J said? I can cancel cosine alpha with cosine square alpha, right? Do I have time, J? Do I have any time, extra time? Can I finish this problem? Can I finish it? Okay, thank you. Then 1 minus sine alpha plus 1 plus sine alpha over one denominator, cosine alpha. Cosine alpha. Now what happened here? We cancel this with this, which is 1 over 1 plus 1. What 1 plus 1? 2 over cosine alpha. 1 over cosine alpha, I'm going to put it here. What 1 over cosine? Secant. 2 secant alpha. Thank you. I have good time. I have 9 minutes more. Okay, good. Okay, I can keep going. Okay. Okay, the same idea. The same idea here. We have cosine x over 1 minus sine x plus. What do you think I have to do here? I'm going to multiply by the conjugate. The conjugate here is what? 1 plus sine x. 1 plus sine x. And the conjugate here, 1 minus sine x. 1 minus sine x. You see? The conjugate of the denominator. If you have a plus, we use minus. If you have minus, use a plus. Okay. Here we have cosine x in the top. 1 plus sine x. Right? Minus cosine x. Or I can multiply, make it easy. Okay. Okay, I'm gonna just, sorry guys, in the bottom we have 1 minus sine square x, and here cosine x minus sine x cosine x. Okay, the first part. And here, I'm gonna use different color here, minus, and the bottom the same, 1 minus sine square x, but here cosine x minus cosine x sine x. Then I'm going to read this again here for you quickly. Cosine x times 1 cosine x, this is the conjugate. Sine x times, which is sine x cosine x. 1 plus sine x, 1 minus sine x, 1 minus sine square x. Here cosine x times 1 is cosine x, cosine x sine x, and minus. And the conjugate, 1 plus 1 minus sine square. And 1 minus sine square equal to what? It's still here. 1 minus sine square is cosine square. Okay. Then this is, we're going to have one denominator, which is from this cosine square and cosine square, right? Cosine what? Square. Cosine square x. Here. Cosine square x. I don't know, my handwriting is very bad. Sorry guys. Sorry. Cosine, I'm going to try to fix it. In the top, cosine x minus sine x, cosine x. And we have the minus here. The minus is going to affect everything here. The minus will be minus cosine x, and here minus and here minus, the plus cosine x sine x. Okay, this guy and this guy cancel, right? And we have this plus this cosine x. Oh yes, yes, I did the opposite. Okay, this is because this is plus here. This is plus. That's good to do something, and because cosine x plus sine x, and which gonna cancel this one. Let me erase. Take this line and this line, and take this line. Here you see that, guys? Because here cosine 1 cosine, look here, 1 plus 1 tan cosine plus cosine sine. Here, minus, right? The minus here. This is going to be plus. Okay. And then here, which one going to cancel? This and this. Only. Then we have here 2 sine x. Look here. And this guy. 2 sine x cosine x over cosine square x. If you watch me for the first time, I said this cosine square x is the same as cosine x square. Okay, cosine x square. Now this guy will cancel with this guy and left only one cosine. 2 sine x over cosine x. What sine over cosine? J. Mike saying, Mike, sorry, I asked J. 2 tan x. Thank you guys. And have a nice day. Thank you and have a nice day.
Thank you.
You're welcome.